Hey folks, this is an introduction into how to run a spatial lag regression in Excel. So it's going to be an applied walkthrough. The question that we're going to start with is, do United States, well, with more residents in poverty have longer or shorter life expectancies, and by how much? So that's what we're trying to answer. We're going to use some spatial data, state level data, 49 cases. You're going to see why in a short while. I'm going to show you where the materials come from. So this blog post is going to be at this tiny URL, blog stats tree. But in here, there is also a link to the materials, which is the Excel file with different worksheets. So we're gonna just jump in, and the first step is to take a tour into Geoda. Geoda is a free software that allows us to create what is called a weight matrix. I'm gonna show you how to do it quickly. The way to do it is to bring in, which means to download from somewhere online, a shapefile, which is pretty much an easy step. These are public files. We're going to use one that has 49 states in it, not the 51. Alaska and Hawaii are not in it. If you open such a file that you download for free, there's a map popping up and you can walk around. If you click on this table option here, you're going to see an actual table. They call it the attribute table. But in here we have the states. You can order by name of the state. So Connecticut, for instance, is this one. The way to use this one is to go to Tools, Weights Manager, and create a weights file or a weight matrix. The only step needed is to tell Geoda which is the state name or the identifier. We're going to use this one. And we just say create, and that's all there is, and we're going to save it. We just saved one of these already, so I'm going to open one for you. The way to open it is pretty much a trick, which is you right click and say open with, and we're going to open it with Notepad. That's because this is a text file. As you're going to see, this is just text. And each state in the Union, in the 49 states set, has two lines. Connecticut, for instance, has a line that says 3, it means the number of neighbors, and then the actual neighbors, New York, Massachusetts, Rhode Island. The way to process this one is to go into Excel, bring it in. So this is the ingredient, this is the text file. We just need to turn this one into a different format, which is a matrix. The way to do it is to take one more step, which means we build a matrix, we copy and paste the names of the 49 states in the same order, and then we just put in a little syntax. And it says, if you find this name up here in the column heading somewhere on the left, then put a true in there, otherwise it's false. So for Connecticut, we have 3 such true statements: Massachusetts, New York, and Rhode Island. And the rest is false all across. And we can change this one to turn false into 0, true into 1s. That's another, we just replace values. And one more step, we just turn those ones into numbers that add up to 1. So for 3 neighbors of Connecticut, we have 0.33. For other states, there's going to be different values, but most of the values in here are zeros in the weight matrix. So now we're ready to run the regression. The regression is going to use percent poverty and life expectancy. So we want to predict life expectancy from percent poverty. Now, the only other step we're doing in here that's unique is we're adding a new variable, which is the lag of life expectancy, which is the outcome. To compute this one, we simply multiply, and that's M-mult, which is a matrix multiplication. We multiply our weight matrix from the other worksheet by the life expectancy vector, which is a column vector. The result is a new variable. Connecticut, for instance, has a new value here, 80.3, which is technically the average of its neighbors' life expectancy. But I also computed this same spatial lag in GeoDA just to check my computation, and they are identical values. Now, the only other one step, which is a few more steps to do, is to multiply some of these predictors in a certain way to replicate this formula. This is from Green, page 23, an econometrics textbook. We just need the matrix or the vectors of the predictors, which is X, and Y is the outcome. This is pretty much the formula. The only other step I did in here was to bring percent poverty, life expectancy, and the lag, but I mean centered them, meaning I subtracted the mean from every one of them. You just compute the means first for each of them, and then you subtract and you get the mean centered variable, meaning they will have a mean of 0. It just helps. But in here, there's also some other steps. We can compute covariances, correlations. We don't really need them, but there's 3 pretty much steps to run a regression. A simple regression of life expectancy on percent poverty is going to yield this regression coefficient, minus 0.44. It's also replicated in GeoDA, which can run simple and multiple regressions and spatial regressions. So we're happy that we get the same number. Now, the spatial regression is a second regression here, which is a multiple regression. We regress life expectancy, the same vector, on percent poverty and the spatial lag of life expectancy. So now we will get 2 regression coefficients, but the regression coefficient of percent poverty changes. So it changes from minus 0.44 to minus 0.31, also replicated in GeoDA. So that's all there is. This is a spatial regression. It's a better way to answer the question, how much less or more do people with living in poverty and higher levels of poverty expect their life expectancy to be? And that's all. It's quite simple.